Hi viewers, welcome back to our channel Raveendra for Students. In this video, we are going to see how to find the capacitance of a coaxial or cylindrical capacitor. So let us draw the coaxial and cylindrical capacitor diagram, then we will see how to find its capacitance. A coaxial or cylindrical capacitor will have two cylinders, one surrounding the other like this. So let us consider this is one cylinder and another cylinder having a bigger radius than this, like this. Right here there are two cylinders, so let us consider the length of the arrangement is L. Right, in this, to have the capacitance between these two cylindrical conductors, the requirement is if the outer conductor is having plus 4 charges, that is 4 positive charges, the inner conductor should have 4 negative charges like this. If the inner conductor is having radius of small a and the outer conductor is having a radius of small b, then due to this arrangement we can find capacitance using the general formula as C equals to Q by V. C equals to Q by V. Now in this arrangement, so actually what happens is, so between these positive and negative charges there exists an electric field E bar. Particularly in this direction, if you consider the radius as rho, so that component will become E rho. Now let us consider how to find this electric field component, and from that how to find the capacitance. So in this, so let us see how to find Q first. So we know this Q can be found using Gauss law, that is double closed integral over S d bar dot ds bar. Then here you can write d bar as epsilon e bar and dot ds bar as it is. So here epsilon is the permittivity of the medium. So here in the diagram we have to represent the epsilon between the two cylinders having the uniform distribution of this permittivity or dielectric constant. Then coming back here, so this is, so epsilon constant, take it outside, then in place of e bar we are having e rho, then take it outside, then the remaining is double closed integral over S ds bar. So this double closed integral over ds bar is nothing but the surface area of the cylinder. So we know the surface area of the cylinder is 2 pi RL. Here in place of R we are having rho as the radius, therefore here it will become 2 pi rho L, where L is the length of the cylinder. Then from this we can write E rho equals to Q by 2 pi epsilon rho into L, or in general the total E bar component in this cylindrical or coaxial capacitor is Q by 2 pi epsilon rho L into the unit vector along the radius, that is A rho bar. Fine, we got E bar in the process of finding the Q. Now, so let us see how to find V. So in order to find V, we are having the formula in terms of E bar, that is given by V equals to minus integral over L E bar dot dl bar. Now here minus, we know it is due to the external work done in the opposite direction of the original force existing. So we know it very well. Then here, so let us consider this as the first conductor and this as the second conductor. So first conductor is having the radius of B greater than the radius of second conductor, which is A. Now here the integral limits will become V equals to minus integral B to A, and E bar we are having already, that is Q by, so this as it is we are writing here, Q by 2 pi epsilon rho into L into arrow bar, and here what is the dl bar along the rho direction? Here the radius is rho, so along rho we know the differential length is d rho arrow bar. So here in place of dl bar we have to consider d rho into arrow bar. Here we are having arrow bar dot arrow bar, which is 1. So therefore V becomes minus integral B to A Q by 2 pi epsilon rho L into d rho, and take all the constants outside. V equals to minus Q, except rho, remaining all are the constants. So minus Q divided by 2 pi epsilon L into integral B to A 1 by rho d rho. Here we need the integration of 1 by rho, so we know very well for 1 by rho the integral is log rho. It is log rho, the limits from B to A. Therefore V equals to minus Q by 2 pi epsilon L as it is, and here in place of rho we have to substitute upper limit as A and the lower limit as B, so it will become log A minus log B. Or here we are having already one minus, so we can write this as, to cancel the minus, as minus Q by 2 pi epsilon L into minus of log B minus log A. So here this minus and this minus gets cancelled, and we will get V as Q by 2 pi epsilon L into, so log B minus log A, we can write it as log B by A. So actually what we want is C is given by Q by V. So from this equation we can write Q by V as 2 pi epsilon L divided by log B by A. So this is the capacitance of coaxial or cylindrical capacitor. So here please observe that B is greater than A, that is the radius of the outer cylinder is greater than the radius of the inner cylinder. So we got the capacitance C equals to Q by V as 2 pi epsilon L divided by log B by A. So we know the units, it is farads, right?